Hello, everyone. Welcome to our third webinar on GCP. We have been doing these GCP webinars over the last month or so. We have been doing one webinar every 3 weeks. This is the third one. The title of this webinar, as you can see, is Best Practices for CI/CD Pipeline on Kubernetes. So you're going to kind of go do a deep dive on how to set up CI/CD pipeline, what are the benefits, what are some of the open source tools that you can use. So we'll cover all of that. We have a demo planned as well for patch management. So we will cover the demo as well. So next slide, please. Quick introductions. So my name is Pavan Udanani. I lead the cloud consulting business for CIC UK out of London. And we have two excellent speakers. Both of them are experts on GCPs. So Alfred, do you want to just do a quick introduction and then we'll move to Ignacio?
Sure. Good morning, folks, or good afternoon, depending on your time zone. Pleasure to meet all of you. My name is Alfred Tommy. I'm a lead cloud architect working for CIC UK. And in today's session, I'll be, teaching you a bit about CI/CD on GCP.
Good morning, everybody. So my name is Ignacio Leon. I am customer engineer in Google Cloud. I am based out in Dublin, and my purpose is to provide with technical support in new projects and advise customers on how best to integrate cloud in their systems.
Awesome. Thanks, guys. So we've got a very straightforward agenda. I'll spend like a couple of minutes on introduction to CIRS. We will then deep dive into CI/CD for Kubernetes. So we'll start with why and what are the benefits, how it helps with the in the DevOps. We will then do a demo for patch management, as I said earlier, and then we'll do the Q&A. So if you move to the next slide, I'll just do a quick introduction on CIRS. So we are a niche cloud agency. We have expertise both on GCP and AWS. We are partners with both of them as well. We mainly work with digital natives. So these are early stage startups, scale ups, and unicorns. Some of the logos you see over here: Flipkart, Ola, Swiggy. All these are huge unicorns which started out of India and now expanding into other markets. So yeah, so we kind of, we started out of India, we are in Singapore, we are in UK, we are in US, we are kind of quite global now, but we mainly work with digital natives. We specialize in infra and app modernization. So this is implementing GKE, applying best practices on GKE, optimizing your GCP environment. We also specialize in data management, so data lake implementations, data pipeline, big data, all of that. Last but not least, we are a team of engineers, right? So we all kind of operate with a very engineering and problem solving mindset. We love to make things better. That's kind of our motto or passion, whatever you call it. So that's about CIRS. Let's dive back into the webinar. So on the next slide, we have 4 key takeaways that you want to get out of this webinar, right? So first is a very clear understanding of the benefits of automated CI/CD pipeline in the GK environment. Hopefully you'll get that today. Also, how to create one using Spinnaker being an open source tool. What kind of deployment strategies can you apply, right, when you're deploying new products and new features? And at the same time, what kind of rollback tactics can you use to make sure that the disruption is minimal if there is an incident when deploying? And then lastly, we'll also do a demo on patch management using Customize, which is another open source tool. So those are the key takeaways, which I hope you will get from the webinar today. And on that note, I'll hand over to Ignacio to talk us through the benefits of CI/CD pipeline.
Great. Thank you. Thank you for the introduction. So in this slide, what I want to cover is briefly what is CI/CD and why is it needed. And to frame a bit the context, I like to introduce the idea that traditionally IT has been always being conceived as a cost center, and therefore meant to justify cost upfront before any project is funded. While we believe that IT done right is a value-generating asset of the company, and we've identified those companies that are high performers. They got this idea properly, and they are able to achieve high levels of throughput at the same time that they maintain good stability on their platform. So these are the two main concepts. Would be IT seen as a value-generating resource in the organization, and throughput and stability being two of the main drivers for that value. So in this context, CI/CD, we think of it as a set of practices to frequently deliver new functionalities to customers. This is done via automation, and by implementing these tools and these practices that afterwards Alfred will introduce to us in more detail, we will be able to do mainly 4 points. Being the most important, increase deployment frequency, and by that we mean to ask, so for the primary application that you are working on, how often does your organization deploy code? So we will pursue to increase the rate, the frequency at which your organization deploys code. Then the second point is to reduce lead time for changes. In example, so how long does it take for you to go from code commit to code successfully running in production? This is the time we are aiming at reducing. Then the third point would be to reduce the mean time to restore, understanding it as, so for the primary application you are working on, we are addressing the question, how long does it generally take to restore service when a service incident occurs? And for example, an unplanned outage or a service impairment. The last point we want to address with CI/CD is to minimize change fail rate. Understanding by change fail rate as the percentage of changes that result in a degraded service or subsequently require remediation. Like for example, it requires a hotfix or a rollback or a patch. So these are the main 4 points why we need CI/CD to be implemented in our organizations. So in this slide, what I want to present is an example of a CI/CD pipeline on GCP using Spinnaker. Now, this is built out of products and services that are available on GCP. Some of them are interchangeable by other products. But I want to present this as a prototype of pipeline, like setting kind of the baseline. So starting from the developer, we start this process by committing code to our cloud source repositories, which is a service that provides you with private Git repositories hosted on GCP. It easily performs Git operations that are required by these developers, and it can also sync with existing GitHub or Bitbucket repos. Now, the next step would be a cloud build, which is a hosted build execution for GCP. It builds container images and also non-container artifacts. You can trigger the new builds based on changes on cloud source repositories or other repos, excuse me, as we've mentioned, being it GitHub, GitLab, or Bitbucket. And also for those of you that are not yet building away, I'd like to make a few points here. The first one is that Cloud Build, it's serverless, so there is no need to provision or manage any servers. And of course, you pay only for what you use. And on top of that, you have 123 minutes per day and 10 concurrent builds for free. Cloud Build is also highly configurable, meaning that any serverless CLI tool can be run as a build step. And it also has built-in encryption for API secret keys. And the last point is that Cloud Build is developer-friendly in the sense that it runs builds locally or in the cloud. And the builds can be manually triggered or triggered on source events. Now, moving along to the next component of this pipeline, container registry, just a couple of points on this service, and is that it's a, again, serverless host image repository for your containers. You can push builds to container registry from Cloud Build, and it can also analyze the images to discover vulnerabilities. This is something that Alfred will cover later on in more detail. And lastly, in this CI/CD pipeline, we have Spinnaker. And a couple of words for those of you that are not familiar with the Spinnaker. This is an application deployment and management platform, which basically takes the pain out of deploying your applications. So you don't need custom scripting. It does support blue-green deployments, canary releases, and manual judgments. And of course, and importantly, as we'll see, instant rollbacks. It also has a single pane of glass for deployments, and it allows you to do deployments in a multi-cloud and hybrid scenarios. And last words about Spinnaker is that it's an open source project. It's led by Netflix, Google, and other CI/CD thought leaders in the space. In this pipeline, we are finishing by deploying to Kubernetes, and there we can see two different applications versions, the production and the canary test, and all is fed back to operations that would trigger alerts and status reports to the developers. And with this, we've covered an example of CI/CD pipeline on GCP, and I'll pass it along to Alfred, who will continue in more detail on this pipeline.
Thanks, Ignacio. Leading off from where Ignacio concluded his session, so I'm going to talk about a generic application delivery pipeline, right? What are the steps involved in your application when it went from conception and development all the way till delivery to production? So here's a sample application delivery pipeline, right? So what happens is your developer is working on the application, he makes some changes to the code, and then he pushes those changes to the Git repository or any source code repository. He creates a new Git tag and pushes it to the repository. So then the CI tool starts taking a little bit of responsibility. It realizes that there is a new Git tag that has been pushed to the repository. So it triggers the container builder, which is in this case the CI tool. It would detect the tag. It would build the Docker image based on the manifest files and the application files available in the repository. It would run some unit testing, and then it would push the image to a container registry or container repository, right? So once the image is there in the container registry, then our CD tool, which here in this case is Spinnaker, would detect that a new image with a certain tag has been uploaded on the repository, post which it goes ahead and deploys that application or that image to Canary or to staging. So once your functional tests have been completed in the staging environment or in your Canary environment, and there would be a manual approval process, which is traditionally the case in most organizations before rolling out to production. There is oftentimes a manual approval process, which is essential to make sure that before your application is rolled out into production, it is airtight and it's secure, and it's all the functional and performance testing has already been completed. So that's what the application delivery pipeline looks like. So I'm going to walk you through on what the CI/CD lifecycle with GCP would look like, right? So for every organization, depending on the mode or the model of development, application development, each organization would have a unique or a custom CI/CD pipeline that would be best beneficial depending on that kind of model that they have, right? So here I'm covering a standard, a fairly generic model of a CI/CD pipeline, but do keep in mind that there is no such thing as an ideal CI/CD, environment for each pipeline for each and every company, right? Everyone has to customize it based on their use cases, based on their development model, based on the release cycles, so on and so forth. So here I'm covering a generic CI/CD pipeline, and the intention is to deliver to two environments, a production environment and a Canary or staging environment. So here I have there are 4 key steps in the pipeline. The first being the source, where your application code is actually contained and committed and modified. Then you have your build and test environment, and here's where the continuous integration happens in an automated fashion. It picks up on changes to the source code repository, builds and tests the application at this stage, post which it passes the baton on to the next stage, which is the artifact management stage. And here your container, here's where your images are actually contained after they have been built. And finally, once you have a working image, all that's left is the delivery. In this case, we're going to talk about delivery using Spinnaker. So let me cover each and every one of these concepts one by one, while also showing you practical demonstrations of the same. So the very first step that we're talking about is the source code step. This is the initial step in the DevOps lifecycle or the CI/CD pipeline. So here we're going to talk about Google Cloud source code repository. So basically, you always have the option of going for your own, using your own repositories on GitHub or GitLab or Bitbucket or whatever tool, third-party tool you might be comfortable with. But if you want to go for a native solution that's well integrated with GCP services, then CSR is a great option for that. As Ignacio mentioned earlier, it basically provides you essentially unlimited private Git repositories that you can host. You can perform any Git operations that are required by your workflow. And of course, it has the ability to sync with existing GitHub or Bitbucket repositories. So here's what it looks like, actually. Here is a sample application that I have, and this is my repository. As you can see here, I have all my manifest files for my deployments. I have my application files as well here. And I have a cloud build file. So this file is actually defines the steps in the CI phase, which I'm going to come to right now. So going back to the presentation, the very next phase in our lifecycle is the build and test phase. And this is where we utilize a tool called Google Container Builder. So this is an entirely managed serverless tool that provides the compute for your build executions. And this can be manually triggered or automatically triggered. In our case, we're going to show you what an automatic trigger looks like. So it's hosted build execution on GCP. It allows you to build container or non-container artifacts. And also allows you to keep a track of your build history. So here is what a trigger would look like, right? So what we're going to do is we're going to keep a trigger that initiates itself every time a new Git tag has been pushed to the repository. That trigger would go ahead and build the Docker image, run some unit tests, and after successful completion of the build, it would push the image to the container registry. So let's take a look at what our container builder looks like. So you can see you have a lot of builds already that are done here. And you can run as many concurrent builds as you want, right? It's not just a matter of 1, 2, or 3. You can run as many concurrent builds as you want. And the entire compute for the execution of the same is managed by Google. So it's pretty easy to handle this serverless. You won't ever have to worry about, matching your infra to your build pipeline. And I've also created a trigger. So if you can see the trigger, how it works is basically that every time I've integrated it with my cloud source code repository, the one here. And every time a new tag has been pushed with this regex expression, with this filter, it's going to go ahead and run my cloud build file, which has a sequence of steps. So there's a build step, there's a run step, and then it just pushes the image to the repository. So that's what it's going to do. And the fact that this entire service is entirely managed makes things very smooth, very easy to handle. So once the build process has been complete, right, that's essentially your CI step. The next part is the actual artifact management. Once you've built the image, where are you going to contain it? And there are certain questions you have to ask when you are using an artifact management tool, like the repository in which I'm depositing my images, is it truly secure? Right? Does it have any kind of vulnerability scanning? Can it actually identify bugs or issues in my application images, right? And is my repository elastic? Can it contain as many images as I would want to host on it? So that's where Google Cloud Container Registry comes into place. It's a very strong, very powerful, very capable tool. If at all you are having an environment on GKE or any Kubernetes environment on Google, it would be a lot more preferable to use the container registry as compared to something like Docker Hub for several reasons. So I'll show you a bit about it, right? So it actually has this inherent feature, which performs vulnerability scanning for your application once that image is pushed onto it. So let's take a look at what I'm talking about. So if I go to my container registry, I can see I have a bunch of images over here, right? And on the right side of my screen, if you can see here, it's showing me the list of vulnerabilities in my application image. So let me go ahead and open this. It's not just showing you the issues, it actually does so much more. So now I can get a more detailed explanation of the kind of vulnerabilities I have in my application, right? I have 21 critical, 120 of them are high, 304 are medium, right? I can actually go ahead and check. So certain errors actually have remediations, they have fixes available. And if I can go ahead and click on this link in the right side column, it actually shows me the remediation as well for that image. So in this particular case, the source package that they're using is Jesse, right? And that it's showing this as vulnerable. And as a remediation, you can actually go for another release, such as security version of Jesse or Stretch or even Buster. So that's just a simple example of how you can actually utilize this tool to patch up your images, make sure everything's airtight, and make sure you have a safe, secure application that you're working with. So that's how container registry is useful. And of course, it's unlimitedly elastic. You can host as many images as you want. So your container registry is actually, the backend storage for that is just your GCS bucket. For those of you who are comfortable with AWS, the equivalent is an S3 bucket. So the backend for your registry is just the GCS bucket. It's an exabyte scale storage. So there's no upper limit on how many images you can host over there. But do keep in mind you will get billed for that, obviously. So, and of course, the entire repository, because it's essentially part of GCS, you can keep it as a private repository. Make sure that only your applications can access the images and no one else. And now we've reached the final phase of our CI/CD lifecycle, which is the delivery pipeline, right? And this is where we're using an open source tool called Spinnaker. So what is Spinnaker, right? I'm sure not all of you might be familiar with this, but some of you might. So Spinnaker is actually an open source tool that was developed and created by Netflix, right? And they were using it for their own Kubernetes clusters at the time. And it truly is a very powerful tool. So the fact that we're mentioning a third-party tool in a Google webinar, right? It says quite a bit for himself. So the USP of Spinnaker, right? It's built for actually these kind of multi-cloud or multi-Kubernetes cluster environments, right? And if you want to integrate all of these different environments into a single CI/CD, centralized CI/CD cluster, then that's where Spinnaker is your go-to guy, right? So if you have multiple cloud environments, you might have Kubernetes on AWS, you might have Kubernetes on Azure and Kubernetes on GCP at the same time, but you want to have a centralized CI/CD platform that's able to deliver to all these environments at the same time, right? Or at least seamlessly. In that case, Spinnaker has a lot of advantages there. It supports multiple deployment strategies as well, which we'll cover in subsequent slides. And in general, it's a fairly simple tool. It's fairly, easy to read, easy to implement, very powerful, especially so when you normally have Spinnaker, right, what you want to do is you want to deploy Spinnaker on GKE. So all the concurrent pipelines that you're running, if at all you are running any at all, can be handled by the creation of further pods. You're not capped by an infra limit either. If you're hosting it on GKE, it allows the Spinnaker pods to scale horizontally to meet up with the complex of the pipeline. So I'm going to talk a bit about the components involved in Spinnaker, and there are a lot of components here. I won't go through each and every one of them, but you just need to know a few of the essential. So specifically the deck. The deck is basically the UI where you can actually access the Spinnaker interface. Your gate, you can think of your gate as your Kube API server, right? It's the point of entry for any API interactions. It has to go through the gate. Right? So any API interactions from Spinnaker to Google or elsewise. And that's why it's connected to Cloud Driver, right? So when you want to make the API call that translates into deployment of infra, deployment of APIs on Google Cloud or any other cloud provider, that's where this component called Cloud Driver comes into play. And Igor is basically your polling agent. It allows you to poll Jenkins and other CI tools so that you can actually trigger pipelines based on those events. And of course, I think the last tool I would like to mention, component I'd like to mention is Orca. So Orca is basically the entire orchestration engine for all of this, right? So it's what enables, it's what allows each of these different microservices, if you will, to communicate with each other in a smooth and seamless fashion. But Let's not talk too much about the various components in Spinnaker. This is just to give you a brief idea on the various on the architecture of how Spinnaker works. So I'm going to talk a bit about deployment strategy. So once your application is built, right, the issue is, how do I release this application to the public in a very smooth fashion, right? I don't want errors. I don't want bugs. And if at all there are errors and bugs, I want to be able to roll back as soon as possible, right? And I want it to have whatever changes I make, I want it to have minimal impact on my customers, at least at first, at least until I build up the confidence to roll it out to the public. So the most traditional and the most standard form of a deployment strategy for the longest time has just been the red-black model, or AKA the blue-green model. It's essentially the same thing. And in this case, you basically have two different versions of your application running on two separate environments. And initially, all your traffic is directed to the blue environment, which is version 1. But as soon as you performed greenfield testing on version 2, you performed your functionality test, you're happy with the application of version 2, right? Then you would actually redirect the traffic and send all the traffic to the new version of the application. And eventually you will roll out or delete the older version or retire the older version of the application. So that's the standard way of incorporating application updates into your CI/CD lifecycle. But this is not the best approach. It's not even the recommended approach, right? So rolling red-black is actually very similar to canary. So I'm going to talk more about what a canary deployment is. I'm sure most of you already know what a canary deployment is, but for those of you who don't know, so the term actually has its roots from the olden days when coal miners used to, they used to mine into these deep shafts and these deep quarries, and they would essentially keep a cage with them, and in that cage it would have a few canaries, right? And at any point, if while they're digging or while they're mining, if the canaries start to scream or to screech, right, then they realize that they've dug too far and the natural gas is seeping up, at which point they realize it's not safe for them anymore, so they leave the mine shaft. So it's basically a safety measure that you keep, and that translates to canary deployments on our applications, right? It's basically a safe way of running your application with minimal impact, with minimum risk. So how it works is you have one version of your code, and majority of your infra is supporting that one version of your code. In fact, most of your users are directed to that initial version. But what you would do is you would route 10% or say 20% of your user traffic to the newer version of the application. And this would be kind of like a beta test model where you would actually rely on your customer feedback, on your application performance. You want to hear, is the functionality good, right? Is the new UI looking good? Is the update satisfactory for the new users? So if you get good feedback, then you can decide to actually roll that out to your entire application. So essentially all your users will get the new version of the application. And usually it's called canary deployment because these are done in incremental fashion. So initially you would route it to 10% of your users, then the newer version would get routed to 20%, 30%, so on and so forth incrementally until the entire user base is being served with the new version of the application. So here's the pipeline that I'm going to be demoing to you. And each sentence here is basically a stage, right? So our pipeline has 4 phases, and this second phase has 4 stages. So the configuration stage is basically the trigger stage, right? When is the pipeline going to trigger? It's going to get triggered when there's an image push on the repository. And then after that, we have to decide, okay, we are going to deploy our application to our canary environment, to our dev environment, essentially, right? So there's a backend application, there's a front-end application, and there are Kubernetes services for each of these deployments, right? Once the dev environment has been successfully deployed, this is the point where you would actually perform your functionality testing, right? You would look at the dev environment, see if any changes are to be made, if the application is buggy or if it's doing perfectly fine. And in the latter case, if it is doing perfectly fine, then it would take you to the next stage, which is the deploy to production. Here, this is a conditional stage, right? So at this point, it would require manual approval. So unless I manually say, yeah, I'm okay with these changes that have been made in the dev environment, please go ahead and roll it out to production. So as soon as I give the manual approval, the remainder of the applications will get deployed to the production environment, and then we can see the change in the production environment as well. So that's the kind of pipeline we will be implementing today. I'll show you a bit about it. And before I, the last one more bit about Spinnaker is just the kind of integrations it has. So being an open source tool, it has a lot of publicly available integrations. When you're talking about your source code repositories, it integrates with Bitbucket or GitHub or GitLab or even Jenkins and Docker Hub. And it's cloud agnostic. It works on all cloud providers. So it also has multiple notification channels. You can send alerts on Slack or Twilio or even email. So it's got a lot of capabilities just from its open source model. Just to make you aware. So I'm going to show you a bit about what our demo looks like. So as you can see here, this is my source code repository. And what I'm going to do here is I'm going to make a change to this. So here is what my application looks like right now, right? So this is this 45 IP address is my production environment, and the 211 is my canary environment, as is depicted by the version over here. It also shows you the pod which is serving the traffic at the moment. So the two microservices, the backend microservice and the frontend microservice, it's essentially this one. Okay, it seems I've been having some problem with, okay, that's not an issue. That's the older tag it's worrying about, okay. So I shouldn't have done that redeployment. But anyway, so what's happening now is that the build has been triggered. And as you can see, because of the pushing of the new tag, my build execution has started. And if I check my container build, it actually shows me the various execution steps that are happening. I can check for more details. I can check the total build time, can tell you how long it took to execute this build, and also tell you the artifacts that were created as a result of this build. So this process, so as you can see, right, I uploaded two tags, right, and as a result, two build executions happen at the same time. So container builder has no issue with this. It can actually accommodate a lot more consecutive sessions. This build process should run for around 4 minutes, like 2.5 minutes more. Once that is done, essentially what we would see here in our container registry is we would see the newer version of the application. And the newer version of the application is, it has the color is blue. So essentially we should see the UI getting changed once the pipeline has been triggered. So once this build process has been completed, the result of that is the image gets created in the container registry. Once the image is there in the container registry, I've created a pub sub topic. So pub sub is basically a messaging queuing system. So what it does is it actually, there is a topic which is listening to this, to the GCR repository. And I've given a subscription, a Spinnaker subscription, which subscribes to that topic. So every time a new image is pushed onto the registry with the tag that's prefixed with V, it's going to send a message to this topic, and the subscription is going to pick up on that message, and it's going to essentially send that trigger to Spinnaker. I'll tell Spinnaker, okay, we've received a new image. Let's go ahead and start initiating the pipeline. So that's how the communication between the CI and the CD happens, right? There's a messaging queuing system in between the two. Once our image is actually created, we can actually also see that at this point, right, after the image build, you can actually include one more step of automation here, right? So to show you what I mean. So right now, as you can see, I have some image vulnerabilities. You can add another layer of automation saying that if there are issues detected here, then please cancel the build or please delete the build and send an email alert. That can also be done. So you might want to add varying levels of automation in this pipeline just so that you can avoid human error wherever possible, right? So the reason why these pipelines in general are almost entirely automated is to avoid the human component of it, right? The only part where we would actually need human intervention is when we are rolling out to production, at which stage we would say, this is an important deployment, please, we need to get manual approval for this. So as you can see, the build is done now, successful build. And as a result, my pipeline should be triggered. Right, so let's wait for the second build to complete also, just to avoid any discrepancies. Right, so at this point, what would ideally happen is that your pub subtopic would send the message, and Spinnaker would start initiating the pipeline. So the build is actually completed now. For some reason, the automatic trigger is not working. I apologize for that. I'll get it fixed later. But for now, it's not an issue. Let's run the manual change. So we can see now that our pipeline is being executed. So it's going to pick up the images in the repository and make these deployments based on the YAML manifests. And it's going to make all these changes in our Canary environment. So this is our Canary environment. Eventually, I should see that this color should change to blue once the Canary deployment is complete. So as you can see, like the Canary deployment is already done now. It's asking me for manual approval to change to production. So let's take a look before we decide on going to production. I made an error with the application code. Let me just take a look. Quick second. It should be rolling out a blue colored application by now. It seems I might have made a mistake somewhere earlier on, perhaps when I was making the new commit. Sorry about that. So this is not the intended result. What we are supposed to see actually is that the Canary version of the application should be giving us a blue UI. I think I might have made an incorrect command, might not have been recognized in the configuration file. But nevertheless, let's carry on. Let's not waste too much
Yeah,
time.
Alfred, I think that's okay. I think we got the gist, right, in terms of how to set up the pipeline. So,
right.
So
I'll tell you what how it would ideally work, right? Assuming that error didn't happen earlier. So this is the Canary version of the application. So essentially, once the change is rolled out, you would essentially see blue on these highlights here. And if I checked my production environment, I would still see the orange, right? Just the Canary would be blue. Once I see the blue look over here in my Canary, I can decide that, okay, I'm more than ready to, roll this out to my production environment. So I just go ahead here and give it the manual approval here. And eventually the same change, as in this case, it's supposed to be changing the color to blue, would be rolled out to my production environment as well. And then if I just refresh this page a few more times, I would be able to see the color blue if I had not made that error earlier on. Again, apologies for that. So now the pipeline is done. The changes have been made to both the older version and the newer version. So what I can do now is say that I am not happy with this. For the sake of assumption, assume the color is blue. Say that I'm not happy with the color blue, right? So I would want to be able to revert my changes. So now there are two ways to do that. There's a simple way to do that, which is, from Spinnaker itself. You can just go to your clusters and you can pick out this specific deployment. So this is the backend Canary, and I can choose to undo the rollout. So it'll take me back to the older version, right? Or, which again, in this case, it would be orange. So no point seeing it. Or additionally, but this thing is like, what you have to do here is you have to apply this to all your deployments. So this is just for the backend. Similarly, you'll have to apply it for the production and as well as for the Canary, right? So you just undo the rollout for all of these, and it can, again, this can also be consolidated. So you don't have to do multiple undos. You can actually do a single undo if you want. You have the option of edit multiple as well. The alternative approach you also have is you can actually revert it using Git itself. So I'm going to revert to version 8 and give it a new tag. And yeah, that's pretty much it. So your pipeline will run again, and it would revert back the changes from the older version, right? So I'm reverting this change that I've made. And eventually, if things had gone a bit more smoothly, you would see that this would go back to orange from blue. And you can see that, but this is not the recommended way. The reason being that if you change it from the repository, then what you would notice is that your build gets triggered again. So it's essentially creating a new build. So the easier way is just to actually undo the rollout from Spinnaker itself, right? So that's how that's actually how we manage a CI/CD pipeline on Spinnaker. Now, one thing you might have noticed, right, is that in my deployment, I have like a bunch of YAML files. Right? I have a YAML file for my backend, I have a YAML file for my front end, and then on top of that, I have two separate YAMLs for my production environment and then for my dev environment or my Canary environment. So this kind of setup gets a little messy, right? So I'm going to introduce you guys to an open source tool called Kustomize. I'm not sure how many of you are already familiar with it, but basically, Kustomize is a tool that lets you create customized Kubernetes deployments on top of your underlying YAML templates. Without actually changing the underlying YAML or the underlying template, you can actually add patches to your Kubernetes manifest files. And this becomes immensely useful, especially when you get to a larger amount of microservices, when you use like 10, 20 microservice range, or you have even multiple clusters and multiple environments. It becomes a very hectic way to deal with all these manifests. So Kustomize actually gives you a very clean, organized way to deal with this. So basically, you have your customization.yaml, and you have your resources, which is like a deployment file and a service file. And you can actually apply changes or patches using that customization file. So let me show you what I'm talking about, right? So So this is in the context of a different application. So I've created a WordPress application. In my dev environment, I have 2 pods running. And in my prod environment, I have 3 pods running. So what I want to do is I want to scale down the deployment on my dev and scale up the deployment on my prod. And rather than changing the individual underlying manifest files, right, which can lead to a lot of human error, what I can do is I can just change the patches on top of it. So this is my file structure. You can see here, I have my base file and I have a base customization file. I have 2 microservices, a MySQL application and a WordPress application. They have their respective resources files over here and over here. I have some overlays. So the overlays are basically the patches you apply on top of these environments. So I'm creating an overlay for dev and I'm keeping an overlay for prod. So let's look at the actual. So this is my customization.yaml file. It just shows me what my bases are. If I look at my WordPress file, if you look at this deployment, right here, it doesn't mention which namespace I'm going to deploy this to. It doesn't mention how many replicas of the pods I'm going to deploy to. It just has a few labels. So what I'm going to do is I'm going to make these changes in real time, right, by adding a patch without actually changing this actual manifest file. What I'm going to do is I'm going to make the change in my dev patch. So if I go to my this is my dev deployment patch. And here I mentioned that I wanted to get, even though I haven't mentioned the namespace in my original manifest, it knows that when I'm deploying to dev, it's going to deploy to my dev environment because I mentioned it in the patch. So I'm going to reduce these replicas to 1 for my dev environment. And similarly, for my prod, I'm going to increase the replica count, say 4. And it's very easy. So this is actually integrated with Kubernetes. So all I have to do is trigger the customize file. So kubectl apply and -k. K is the flag for customize, just FYI. So I'll just go ahead and keep the change in my dev. And voila, I think now if we take a look at our dev and prod environments, you can see that my dev is now scaled down to 1 prod, and my prod environment has scaled up to 4 pods. And that is like a really simple way of patch management. So it's not just namespaces and replicas, right? If you want to add labels on top of it, right? If you want to make any kind of changes to your manifest without actually changing the underlying manifest, this is the best way to do it. And although I've showed you this demo in an isolated fashion, traditionally what you would want to do is you would want to integrate it with Spinnaker. So when you integrate it with Spinnaker, right, you don't even have to like make these manual changes that I just showed you, right? I ran these commands manually. That wouldn't even be have to done. So the moment Spinnaker realizes that I'm deploying to my dev environment, it deploys using the customized manifest. So this would automatically happen. This kubectl apply k, it would automatically happen and deploy to the dev environment. I wouldn't even have to manually trigger it or anything. And every time I want to make a change to this, every time I want to make a change to a manifest, I do not have to go and touch the underlying or the original template. All I have to do is just change the patch file, and that's it. Rerun the reapply the customize, and it's good to go. So that's a very useful tool that you can actually use, especially when you get into these larger microservices, larger quantities of microservices, and you have this huge mess of YAMLs that you don't know how to organize. That structure I showed you there, that same structure you would want to implement in your this kind of structure you would want to implement in your repository. So I think that covers like everything that I want to talk about today. So far, what we've learned is we've learned about a CI/CD pipeline. We learned about cloud source repositories, container builder as a CI tool, container registry as an image repository for images, how it does the vulnerability scanning on its own. We learned about Spinnaker as a delivery tool, and I showed you a demo on how a pipeline is executed. I think I hope all of you understood the gist of how you can actually roll out updates and roll them back as well. So with that, I'd like to conclude the session, and over to you, Pawan, before we can,
Yeah, thanks, Alfred. I think you covered a lot of ground over there. All right. On that note, I would close this webinar. Hope everyone had a useful session, and see you next time. The next topic is horizontally scaling databases. That's in July, so we'll be in touch with that. Thanks, everyone.